Hello, this video is focused on the big three kinematics equations and how to use them in problems. There is another video that shows you how to derive the big three kinematics equations from our known equations. So feel free to go watch that one if you want to know where these equations came from. This one is about how to do problems. So we're on page 19 of our notes, and we see that there's three different formulas. And what's nice is you can use them for different scenarios. So each one of these formulas does not include one of the following things: VF, VI, VA, or A, the acceleration, time, or the displacement. So for example, this first formula, VF equals VI plus AT, has all of these except for the displacement. For the second one, it has all of them except for the final velocity, and for the third one, it has everything except for time. So what's useful is you can, you're going to need sometimes to just use one particular equation. So for example, if we look at number 1, it says an automobile is moving in a straight line towards the east when the driver puts on the brakes if the initial velocity is 15 meters per second. So VI is 15 meters per second, and it takes 5 seconds, so our time is 5 seconds, to slow down to a final velocity of 5 meters per second. What is the car's average acceleration? Well, in this problem, we're asked for acceleration, but we aren't given any information about displacement. So the best formula for us to use is the first formula because it has all the things that we want: VF, T, VI, and it's looking for A. So all those variables are in the formula. So that's a useful formula for us. VF equals VI plus AT. So 5 equals 15 plus A times 5. So we'll just subtract 15, and I get negative 10 equals 5 times A. So I'm just kind of rearranging that. So then I divide by 5, and I get A equals negative 2 meters per second squared. The next problem asks, how long does it take a car to travel 30 meters if it accelerates from rest at a rate of 2 meters per second? So let's write down what we know. Let's look. We are asking for how long it takes. So that's time. We know the distance is 30 meters, that it accelerates from rest. So my initial velocity is 0. And it accelerates at a rate of 2 meters per second squared. We're looking for the time that it takes to travel 30 meters. So we'll use that second equation, d equals VIT plus 1/2 AT squared. Because we weren't given final velocity, and we're not interested in final velocity, we're just interested in time. We know displacement, we know initial velocity, and we know the acceleration. So you could solve this for time first. We're not going to do that because that's a quadratic, t and t squared. But what's nice about a lot of these problems is the objects start from rest. So the initial velocity is 0, and we multiply that by t, and we add 1/2 of 2 times t squared. So 0 times t is just 0, so that whole term is gone. 0 times t is 0. So we get 30 equals 1/2 times 2, which is just 2, t squared. We'll just take the square root of both sides, and we get t equals 5.48 seconds. So we'll do just a couple more. A jetliner must reach a takeoff speed of 80 meters per second. If the runway is 1,500 meters long, what is the acceleration? So the takeoff speed would be the final velocity after it's gone down its runway. The runway is a distance of 1,500 meters long. We're looking for the acceleration. We're going to assume that it started from rest. Most of the time, it will actually state specifically that it started from rest. So in this problem, we're given everything but time. So we need to use our last formula because we're not given time. So we'll use VF squared equals VI squared plus 2AD. So VF squared, 80 squared, equals 0 squared, plus 2 times A, which we don't know, times 1,500. So 80 squared is 6,400. And this is just 0, so we're just going to say it's 0, ignore it. Then I'm going to combine the 2 times 1,500 just for this next step, because all this stuff is multiplied together. So I can say 3,000 A divided by 3,000 divided by 3,000. Pause for calculation. So that answer is 2.13 meters per second squared, which is our units for acceleration. So this next question is about my car. My former last name was Arnold. So at highway speeds, my new car, her name is Yaya, she's a Yaris, she's pretty awesome, can accelerate at about 1.7 meters per second squared, which is not that great of an acceleration, but great for a Toyota with great gas mileage. So at this rate, how long does it take Yaya to accelerate from 2.3 or 23.6 meters per second to 28 meters per second? So we're looking for the time, how long? So we need to use an equation that involves time. We know Yaya's acceleration is 1.7 meters per second squared, and we're looking for the time it takes to change its velocity by that much. So I'll just call it initial velocity. We could calculate the change in velocity, but it's probably not necessary. And so we have VF, VI, A, and we're looking for T. So we can use VF equals, so that's equation number 1. VF equals VI plus AT. There's no distance in this, and we weren't really given distance, so it's not that. So I plugged in my numbers, or I substituted. I'm just going to solve. So now I am going to find that difference. Minus 23.6. So that is, pause for calculation, 0.4 equals 1.7 t. Just divide by 1.7, divide by 1.7, and we get t equals 2.59 seconds. So now we're looking for how far did I travel in that time? And luckily, we have v final, v initial, acceleration, and time. So we can choose either of the equations that involves displacement. So either number 2 or number 1. I'm going to choose number 2. So d equals VIT plus 1/2 AT squared. So VI is 23.6. T is 2.59 plus 1/2 of 1.7 times 22.59 squared. And just as a heads up, this is the what everyone forgets. So if you did any miscalculation at any point, it's likely that you forgot to square that time there. So that distance is 66.8 meters. That's a pretty reasonable distance for a car to be traveling. 5 9 seconds. So these are a few examples of how to use the big three kinematics equations. I really, really strongly recommend that you follow the same structure that I did when doing these problems. And that structure included writing down the given information in the problem first, identifying what we're looking for, then using that list to help us choose which of these formulas to use to solve. So we can only use a formula that involves what we're given and what we're looking for. And that's about it. Happy to answer any questions. See ya.